Three projectiles are launched at the same initial speed but different initial angles. A is launched at 25 degrees, B at 45, and C at 65 degrees above the horizontal. In Kinematics 19, the water demo video lesson, we learned that on level terrain, at the same initial speed, a projectile launched at 45 degrees above the horizontal will land the farthest. And at the same initial speed, projectiles launched at 25 and 65 degrees above the horizontal will land equal distance away. They will land equal distance away if the angles add up to be 90 degrees. For these three projectiles, rank from high to low according to 1. The time of flight, 2. The landing speed, and 3. Their speeds at maximum height. For time of flight, we can look at the vertical motion, because the time stops when a projectile hits the ground. For vertical motion, all three projectiles have the same acceleration. So the one reaches the largest maximum height must start with the largest vertical initial velocity and takes the longest to get there. So the time is C and then B and then A. As for the landing speed, all three projectiles land at the same height as the initial height. So for each projectile, the upward trip and the downward trip are symmetric. The landing speed equals to the launch speed. Since they all start with the same initial speed, they would all land at the same speed. So this one is A equals to B equals to C. 3. Speed at maximum height. At the maximum height, the speed of the projectile is not 0. What is 0 is the vertical component of the velocity. The horizontal component of the velocity is still there. So the speed of a projectile at the maximum height is the magnitude of the horizontal velocity. The three projectiles are launched at the same initial speed, but at different angles. The smaller the angle, the larger the horizontal component of the velocity. So the ranking for this part is A, and then B, and then C.